So we're going to continue here in section 3.2, talking a little bit more about complex numbers, including the imaginary number. So we're starting on page 127. So in this lesson, we're going to learn to perform operations with complex numbers, which have a form similar to linear binomials, such as 3 plus 4x and 2 minus x. So how would we add those two binomials together? Well, first thing you do is you group the like terms. So you take all the constants, so that'd be 3 plus 2, and then we take all of the terms with the x's, so that'd be 4x plus negative x, add the whole numbers, 5, add the x's, you get 3x. How would we subtract? We do the same thing. Well, they rewrite it as an addition, so that would be negative 2 plus x. Then again, they do the grouping, so 3 plus negative 2, 4x plus x, and combine the terms 1 plus 5x. Multiplying, we use the FOIL method. So we take the first terms, 3 times 2, take the outside terms, 3 times negative x, and take the inside terms, 4x times 2, which is 8x. And then you take the outside terms, or the last terms, and you take 4x times negative x would be negative 4x squared. So when we combine our terms here, we get 6 plus 5x plus negative 4x squared. So now instead we're going to replace x with our imaginary number I. We'll get 5 plus 3i. We'll get 1 plus 5i. And then the multiplication is where things get a little different because we got that x squared term, so that means we have to square the I. So if we write it with I, we have 6 plus 5i minus 4i squared. So you have to remember that I squared is the same thing as negative 1. That means we're taking 6 plus 5i and then plus 4 to get a simplified solution of 10 plus 5i. So anytime you have a product, you should come back to this kind of thing, which is called a complex number. You shouldn't have any I squareds in your answer. You should be able to simplify. So when we define what's a complex number, it's any number that can be written of the form a plus bi, where a and b are real numbers. So you have a is just the number portion, b is the coefficient in front of the I, and again we say I is the square root of negative 1. So a is called the real part, and b is called the imaginary part. Notice that this imaginary part refers to the multiplier or the coefficient in front of I. It does not refer to the whole thing bi, it's just the coefficient in front. So here you can kind of see a Venn diagram of what this means. So real numbers are numbers that are just a number. Imaginary numbers have the I with it. And then complex is when we're adding or subtracting them together. So notice that the set of real numbers is a subset of the set of complex numbers. Real numbers are included as complex numbers. That's because a real number a can be written of the form a plus 0i, whose imaginary part is 0. Likewise, the set of imaginary numbers is also a subset of this set of complex numbers, because an imaginary number bi can be written of the form 0 plus bi. So if something is a real number, it has to be real and complex. So if we want to identify the real and the imaginary parts, and then say which set it belongs to. So 9 plus 5i. The real part is 9. The imaginary part is 5, just the coefficient. And then because both the real and imaginary parts are non-zero, it only belongs to the set of complex numbers. Here in B, we've got negative 7i. So the real part here is 0. We don't have just a number term. The imaginary part is negative 7. It's that coefficient in front of the I. So because the real part is 0, the number belongs to both imaginary and complex. So in A, it's in just complex because it's got two terms. Here in B, it's just it's the imaginary and the complex. So we want to do this ourselves. The real portion, just the number portion here is 11. Imaginary portion, since it's not there, it's actually 0. So that means it belongs to both the real set and the complex set. Over here in number 5, the real portion, the just number portion is -1. The imaginary portion is the coefficient in front of the I, so that's a 1. Since it does have a real and an imaginary component, it's in the complex, just in the complex. Whoa. There we go. So when we add or subtract the complex numbers, you add the real parts and the imaginary parts separately. So all you're doing is taking the real parts and the coefficients here on the imaginary parts. So you group the like terms. So -7 plus 5 gets you -2. 2 and -11 gets you -9i. Pretty simple, just adding the like terms. So if we group our like terms here, that means we have 18 and then -2. That's our real portion. And then 27i minus 3i. 18 minus 2 is 16. 27 minus 3 is 24i. So is the sum a plus bi plus a minus bi a real number or an imaginary number? Well, if we take our real parts, we take a plus a. We take our imaginary parts, bi minus bi. So notice we'll have 2 a's over here, 0 i's over here. So this will be a real solution. There is nothing here in the imaginary part. So it will be a real number solution. So let's do it. So we take the real parts. 17 minus 9 gets us 8. -6 minus 10i will get you -16i. Over here, if we add 16 minus 8 gets us 8. 17 minus 12 gets us 5i.